Einstein's thought experiment about the equivalence principle suggested there was no way to tell if you were dropping an apple on the surface of a planet or in an accelerating rocket. Similarly, if you are drifting weightless, there is no way to distinguish between being in outer space or in a falling elevator plummeting downward. This bothered Einstein. He began to wonder if there was any way to tell if you were being influenced by gravity. To answer this question, he imagined making the small rooms in his thought experiment much larger and dropping 2 apples at the far ends of the room. If the large room is really an enormous rocket being pushed uniformly out into space, then the apples fall straight down, parallel to the walls of the room. Suppose instead the large room is hovering over a planet. Here we imagine a room about the size of a planet. Now you can do the same experiment and drop 2 apples at far ends of the room. In this case, they appear to fall inward, landing closer together when they hit the floor. Their paths are not parallel. So what's going on? Remember, the planet has a gravitational field, always pointing inward to the center of the planet. The falling paths of the apples follow the shape of the planet's gravity. So Einstein began to think about parallel lines. If 2 cars are on a flat piece of paper and start traveling along parallel paths, no matter how far they travel, the lines they move along always remain parallel. The big room thought experiment showed that one way to detect gravity was to look for initially parallel motion becoming not parallel as objects move. Einstein wondered if there were examples of this in mathematics. As it turns out, there are examples. Imagine a globe with our 2 cars heading out on a journey from the equator. Initially, they drive on parallel paths due north. As the journey winds on, the parallel paths become not parallel until eventually they cross at the North Pole. Why does this happen? Because the surface they are moving on is curved, not flat. This is the key idea that will lead us to general relativity.